Okay. Graphs of exponential functions. So we just did absolute values, now exponential functions. So, on your calculator, what is 2 to the negative 2? You gotta be careful with that. 2 caret negative 2. Do it. 0.25. Which is 1/4. Okay? 2 to the negative 1. 0.5.
Oh my God.
Anything to the 0 is 1. 2 to the 1 is 2, and 2 squared is 4. Okay? I don't know why I wrote 0.24. I was thinking 1/4. So 0.25. So I'm going to start backwards. I'm going to go 2, 4, 1, 2, 0, 1, and then I'm just going to do it like so. It's never going to hit 0. Okay? The exponential function is never going to hit 0. Now, this one's a little bit different, because this is 1/2. So, what's 1/2 to the negative 2? Put your calculator, put 0.5 to the negative 2.
16. It's 4. Oh, it's 4. I got 16. Wait, are we doing 0.25 or just 0.5?
Well, 1/2 is 0.5.
I did it wrong.
What's 0.5 to the negative 1? So you're on 2.
2. Oh yeah, I got it.
Anything to the 0 power is 1. 1/2 to the 1 is 0.5. And 1/2 squared is 0.25.
Is it always gonna be 1 and then 0.5 and then 0.25?
No.
Okay.
That was just because this was 2 and 1/2. If it was 3 and 1/3, it'd be different numbers.
Okay.
So, negative 2, positive 4. Negative 1, positive 2. 0, 1. You can see what this one's doing. Same thing, just going the other direction. Because this is decay. Okay? So the first one, this one is growth. This is 2. Now the 1/2 is decay. Now, careful, pay attention. These notes are going to apply only to the parent function. Only the parent function. The y-intercept is always going to be 0, 1. Notice for both of these, you've got 0, 1. Because anything to the 0 power will be 1. So as long as we're not adding or subtracting anything from that function, transforming it, it's always going to go through 0, 1. Now, there's an imaginary line called an asymptote. An asymptote. That the curve gets really close to. That's how we talked about that electric fence. Okay, it won't ever hit that. Asymptote. asymptote. Now again, remember, this only applies to the parent function. The asymptote is the x-axis. As long as I don't say plus 3 or minus 3 and move that bad boy up or down, the x-axis is the asymptote. Now, if the base function, the base of the function is greater than 1, the function is growth. Okay. If the base of the function is greater than 1, it's growth. And that shows an increasing relationship. If the base of the function is less than 1, then it's decay, which shows a decreasing relationship.
I just hurt my neck.
The domain is always going to be all real numbers. It's going to go left and right forever. And the range will be y is greater than 0. Notice, not greater than or equal, and it's never going to hit that line. It will never hit the x-axis, ever. Now remember, all of this, all of that we just talked about, only applies to a parent function. Okay, so we're going to sketch these. So, this question came up before. Will those numbers always be the same? No, they will not, because now we're dealing with 3 to the something. Okay, so in your calculator, what's 3 to the negative 2?
21.
What 1? What's 3 to the negative 1? No, 0.3. Now notice, not transformation, still parent function, so 0 was always going to give us 1. 3 to the 1 is 3, and 3 squared is 9. So we're going to graph this now. I'm going to start at the big number, so 2, 9 is going to be up here. 1, 3 is going to be right here. 0, 1 does not change. And instead of trying to graph these tiny decimals, I'm just going to do this and write it out. So we'll never touch the line. So the domain, again, is all real numbers. And the right range is always going to be greater than 0. Okay, 0.2. That's 2/10 or 1/5. So this is going to be a decay. This means it's going to be going the opposite direction. So what's 0.2 to the negative 2? Calculator. Now, 0.2 to the negative 2. You should be typing this on your calculator now for practice. What'd you get? 25. What's 0.2 to the negative 1? 5. 0.2 to the 0? Not going to change. It's going to be 1. 0.2 to the 1 will be 0.2, and this will be 0.04. Now, negative 2 to the 25, that's like way up here. It's off the chart. So all we can do is negative 1, 5 and 0, 1. And again, it's going to ride out here like that. So this one is a decay. Again, I don't try to graph these right here. I just graph the bigger side and then just write out the line. Domain does not change. Range doesn't change. Okay, 1.5 to the negative 2. What is it? 1.5 to negative 2. You should be practicing putting this in. Everybody should be handling their calculator right now. If you're not practicing this, you don't know if you're doing it right when you do the practice. Hit 1.5, hit the caret button, then negative 2.
It's 0.44.
Right, it's repeat, 0.4 repeat.
No, it says there. Shut up.
Actually, use the minus key instead of the negative key.
You tell us. So that's 10.8.
So 1.5 to the negative 1. So everybody put your calculator. 1.5. Caret. Negative 1. It is 0.6. Anything the 0 power is 1. 1.5 to the 1 is just 1.5. What's 1.5 to the 2? No. Put it in your calculator.
Maybe next time.
1.5 squared.
2.2.
Okay. So this one's going to be kind of hard to graph because it's all small numbers. So 2.25 is going to be a little bit above that. 1.5 is going to be halfway there. So this is going to be really drawn out and wider. And it's wider because the base.